insulation and all the types of insulation that goes everywhere. If I want to expand and show exactly what type of insulation, I have all that already calculated over here. And it's showing by space, which is super important for the insulation industry. Drywall, same thing. As you noticed, I have trained the model to identify exterior walls versus interior walls.
Welcome. Let's look at a lot of blueprints today and get to know one company, Blueprint Pro AI, that is using computer vision to analyze blueprints and hopefully speed up the home building process for everybody. To help us explore this topic, today we are joined by Filipe Mendes, who is the CTO of Blueprint Pro AI. Filipe, would you like to introduce yourself? Say your name again, because I probably butchered it at least once so far, and will do
Don't
so
worry.
many more times.
Well, my name is Felipe Mendes. Felipe Mendes. You can say Felipe like Mississippi. Mendes, just imagine that you don't have the ES. Mendes like DS. I'm from originally from Brazil, so this is how the Felipe comes in play. Some people think I'm from Italy or some sort of Europe area, but it is from Brazil. I'm very proud of being Brazilian. I mean, we've been living in the US for 10 years now. It's been great. But yeah, that's who I am. And if you, I mean, if you allow me to talk about a little bit my, technical background. I've been working with technology for several years. It's about 17, 16 years. Yeah, we have Brasileiros on the chat. I see a comment right now, which is fantastic. Hello to my Brazilian fellows right there. Yeah, we've been working. I'm from Belo Horizonte, Minas Gerais. It's the southeast. A city in Brazil, which is amazing, very known by its food, really good food. And yeah, I when I was 17, I was a trainee on a tech company, and it's been a fantastic ride since then. I spent my first college degree was in graphic design for technologies. So it was aiming this kind of technology. And then the second one was computing graphic. And then I did a master's in game development. Nothing related to vision computing at all. But, as the years goes by, working in many different software companies, some big techs, some other major companies in the industry, I got involved with coding, right? So then is where I decided to accept and move to the dark side of the force. So I start to engineering, coding, that kind of stuff, and oh, so it's and then I kind of was able to use my knowledge when it comes to image analysis and imaging generation based on my background, right? And I found Vision AI very suitable. So I touched the water when I found Roboflow. And it's been a great experience. I've been working and playing with Roboflow for a long time. And learn how we can create cool models that will solve real problems. So that's
Nice.
a small, short version of my background and what I have done in the past.
Cool. All right. Well, I want to talk a little bit about blueprints, which is the topic of today. And full disclosure, I live in a house, but I have never built a house before. So, until recently, I hadn't heard this term blueprint takeoff. What is a blueprint takeoff? Do I need one? When do people need these?
Yes, that's a really cool, nice question. A blueprint takeoff, it is a material list. If we simplify, right? It's there that the builder will find the list of material and the quantities, and the measurements, everything that is necessary to build the house, or just do a renovation project, or to identify based on the blueprint, which is the drawing of your home, this kind of 2D drawing you have in PDF that's most people have when you own a property or something like that, um, will allow you to identify, oh, this is a load-bearing wall. So what is a load-bearing wall? It's a wall that is sustaining something really important in the house, so it cannot take the wall down. Otherwise, the house is just gonna fall over you. So that's kind of thing. So it's super important to get to know what kind of materials you need, what is being specified. There is some specific codes and regulations you gotta follow to make sure that the house is being well built and it will sustain, the natural events of nature, wind and hurricanes and all that kind of stuff.
Cool. All right. Tell me a little bit about I think you mentioned this to me previously, but kind of like what's the challenge out there for the world when it comes to making these blueprint takeoffs and compiling these lists of materials?
Yeah, when I received the challenge, it was pretty much like 2 years and a half ago, kind of deal. The turnaround time for delivering a takeoff used to be 3 weeks. So people were taking 3 weeks, and then if they had any revision, anything they want to update, it will be 1 extra week. So that was like a month turnaround time from the time that you have requested a blueprint takeoff to the time that you need the list to buy the material. So by this time, you have lost the drive. Like, I don't want to do this anymore, right? I don't want to build this. I just like it's a month later. Like, I'm not in the mood to build anything anymore. So big box stores, big lumber yards, they were just losing projects and monies and biddings just because people were just giving up, right? They just give up on waiting. And I have a great partner, my CEO, Bradley. He brought this problem to us, and he was like, "Hey, Felipe, can you find a way to reverse this or create something?" Because they were creating software together. Like, yeah, let me take a look. And I was studying some AI initiatives, even with those short classes and courses from Harvard Institute. It's really helpful. Helpful if you want to get to know the things, how things work in the back. So I was in the moment I was studying, even deploying some small projects using AI, some LLMs and stuff. And and say, yeah, let me find a solution. And then we start to look into vision AI. Say, hey, I was able to create a proof of concept. Here it is. And then we are evolving this proof of concept to the point that now I can give you a takeoff in less than 10 minutes. And and by this time, when I say 10 minutes, I mean the whole process will take 5. And if you give me more 10 minutes, I will have a person that is trained to verify everything that is matching with the descriptions, matching with the code, and give you a verified blueprint by a construction professional. Blueprint Pro AI is not a software company. We are a service company. We provide the service of giving you the takeoff, and those takeoffs comes with a whole background of knowledge of civil engineers that's been working on training these people that will provide you great takeoff files that is ready to be used on construction, on to buy the material and everything. So it's with verification, I will give you this in 15 minutes. It's been a great moment for AI in construction because first, we did not eliminate the human in the loop, which would generate jobs. And we also speeding up the process of construction will also generate jobs. We're really proud to say that this is one of the few AIs that is not taking jobs away. Actually giving you more work, I mean, allowing you to perform better and deliver with a short time. So that's pretty much what it is.
Cool. All right. Well, on this topic of Blueprint Pro AI and this solution that you've made to help cut down on the duration that it takes to create these takeoffs. I think you prepared a demo for us today. I'll stop sharing my screen and we could switch over to your screen and you could walk us through the solution so we can see it in action and see some of the cool capabilities.
So this is the screen to create a new one using our software. Zip code is necessary because we do have a sort of validation. We will get climate zones based on the location of this blueprint. Let's say if you're on south, your installation would be different from somebody that lives on north. The house has to be more insulated because of the cold weather. So the first thing that's happening here, we are extracting images from that PDF. It is showing exactly what it is. The process is because we train our models to identifying things on images. Most of Vision AIs work with bitmap type of files. And this is one of the cases. We're using a bitmap, which is an image, extracting those images. And then the first process that we do here is a classification model. We're using a classification model to identify what it is. Is this a structural page? Is this a roofing page? Is this a a cover. So because I have nothing to use in the cover besides something that we use in other processes. Just giving you guys an idea, we have about 29 models running in the background to solve this problem. It's not just one single model problem.
Hold
This
on,
is
that's
something, right?
I do want to highlight to everybody like 29 models, that's all in the same pipeline, right? Like
Mhm.
you start a task and then we have 29 different vision models.
Yes. And this is where, this is the first categorization. It's all done by AI. And of course, I can have a human in the loop to say this is structural because the model has found this corner right here has a structural part. So I can, if I even want to isolate this, I can go here and do some small interaction, which is going to be pretty much the only interaction. Say, hey, I want to emphasize that this is my structural side. So my next processes will only consider this part of the page as the structural. And of course, I also have that same page as notes because I do have notes over here, which is which is going to be used by our RAG to extract more information. So we have a lot of things going on. So the RAG will extract information to then serve as a base for the analyst to then perform the verification. Elevation, which is outside the house, slopes, which is the roof. It's classifying right the foundation, give me the foundation pages right here. I can see all the foundation stuff, some joists, some electrical as well. We have models on electrical, but we're not going to highlight this at this demo. And of course, mechanical, which is AC, and plumbing, which is plumbing. From this, it's all good to go. The AI has successfully found everything. I don't have to change any categorization. I would just move on to the next step, which is now is going to be the whole pipeline of models. So now the whole pipeline is processing each page how it's supposed to be, and this is the fun part, and it's spinning, it's doing the inference. This process usually take roughly, depending on the size of the blueprint, 3 minutes. It is already on 76%, 80%, 81, and it's
I'm still just thinking about this number of 29 different models
yeah.
in the same pipeline. And I really love that example because you and I were talking about this previously, but
Mhm.
um, well, and maybe I could just ask you this question, like, was there ever a time where you thought we can just make one big model that can solve all of this? Or did you come into this knowing we're
No,
going to have to make like a pipeline of separate different models? And can you tell me a little bit about that?
sure. When Bradley was brought in the problems in pieces, this is something really interesting. He was delivering the problems in peels and say, now we gotta do the walls, now we gotta do the plumbing, now we gotta do electrical. Like, holy cow. It was naturally becoming a multi-model as we go. And now looking to the solution, and we definitely try. There you go. The blueprint is ready to be analyzed. It's done. Um, and as he was bringing up those solutions, those problems, not solutions, I was thinking solutions about them. And let's say, hey, if we gotta keep consistency on multi-model, because one thing that we learn is give the model a easy task and your success rate of keeping consistency will increase. So consistency when it comes to blueprint industry, it's something that does not exist. Every engineer, every designer will draw the file in their own way. They were using Comic Sans to give really hard details to read. Like they don't have a standardization for fonts. They don't have a standardization for anything, for wall type, for wall size, for the sink, the little bathtub you see on the blueprint right here. Like they don't have like nothing. There's no standardization for toilets. There's no standard at all. So that requires us to buy a huge amount of blueprints because we gotta buy them to then train the models. We gotta own the data, right? Um, and yeah, that was pretty much the most painful thing that we had to do to perform a inference. Yeah, in multi-model, like I mentioned before, that is an average 29 models depending on the case. This is one of the case that use those 29s. And we have a bunch of information here. As we can see, we have multi-colors, which indicates multi-heights. I'm also based on instance segmentation, being able to take information from each space and find the height of each space. So that is also a communication with our own VLM that does the analysis on each space and then give us the information that we need about the heights. So that is a lot of cool things that we use to give the answers that we need. Like all the components like headers are here. All the roof framing, it's here. And of course, this is a pre-validation, but let me show you a validated result, how it looks like. This is pre-human. The team has not started validation because I just processed all those cool little things. This is object detection. And if I can zoom in here, you will see that we have found all the windows. If I zoom in here, I can show you all the doors, different types of doors. Which is a French door. This is yellow one is a French door. Insulation and all the types of insulation that goes everywhere. If I want to expand and show exactly what type of insulation, I have all that already calculated over here. And it's showing by space, which is super important for the insulation industry. Drywall, same thing. As you noticed, I have trained the model to identify exterior walls versus interior walls. That's another feature we have. We have a model that does do that differentiation on finding those different type of walls. Interior finishes would be used for flooring, right? For paint, that kind of thing that generally need some specific spacingness. And notes, that would be pretty much all the notes on additional notes, as I mentioned in the beginning, which my validator can look to find specific details. Let me look into one that was previously validated. This one, for instance, it shows exactly what it needs to be shown. It was delivered to a client. I mean, not as a real product, but as a test. If you go here to exterior, you'll see that the soft is also able to do natural roofing, metal roofing, siding, which is what exactly material that goes on everywhere, different type of materials. Those materials will also be quantifying. Exterior framing, which is a different lumber for just exterior, and trim, which is all the trimming around windows and doors, which is necessary as well. And yeah, it's all here, all validated. If we check, all the elements are being found and well descripted. As you can see on the sides, all the Windows 350, 350s right here, 6 units. Um, yeah, this is our challenge. And my client will get an option to see all the list of materials right here. They can even manipulate and change values, add wasting factor, which is a factor that we add based on we cannot run short of this material, and then we calculate some extra material based on wasting factor as well. And then we can export for PDF, Excel, CSV, and we also split them by floor. We also have a process where using a VLM that will identify the floor on the page and gives me the material for that floor, so forth. So it's pretty cool. We have done a ton of work just on vision models. As I mentioned before, we have 29 running at this time. Yeah, this is what we do. This is what we had discovered.
Beautiful. There's I saw actually a couple questions that might
Mhm.
make sense to talk about now. I see that Anthony asked about for getting room perimeters, do you segment the negative room space, or do you segment for walls and then kind of infer the rooms from the walls? So I guess, are you like identifying the room itself, or are you just identifying the walls and then understanding that there's a room inside there? Or
Yeah,
is this way more complicated than this
it's really,
question
yeah, it's way
frames
more.
it?
Yeah, it's a bit more complex than that. We do have a way to find that that wall belongs to a room, and then based on that, we're able to have all the calculations and estimations based on that specific principle. A wall can be shared by multiple rooms at the same time. So this wall here next to me, it's also the wall that goes to the garage. So it is very complex, but it is very doable. I mean, it took
Uh,
us a lot of research to get to the point, but we did it.
Nice. Yeah. Well, that actually leads into perhaps my kind of like next chain of questions, and I see that we also got a couple that are similar to this as well. Also, you have some very nice comments right now about the project in general, so that's cool to see.
It is.
Um, but could you tell me a little bit about you mentioned this earlier about your history of kind of the things that you've been working on. and some trainings that you did online before this. But, before you got started with this project, like maybe I'll have two questions. One is like, did you consider yourself a machine learning expert? And also my other question is like, did you consider yourself a blueprint expert? And like, there's so much, how should I say it? There's so much industrial knowledge that you would need probably to kind of train these models to understand what they're looking at. So yeah, could you kind of tell me a little bit, maybe the first question, like, were you a machine learning expert, computer vision expert, and then also were you a blueprint expert? How do you solve that?
Cool. Well, based on the studies and the knowledge that have accumulated throughout the past 3 years, it's been recent. I cannot call myself a specialist. It's too early for that. It's too soon. But I do
I
have.
think I'll go. I'll tell you. I think at this point you're an expert.
Oh, but I do spend a ton of time reading, researching. I do have what do I do on my Sundays? I study. I go learn how can I do this better? How can I do this faster? And I trying to find joy and fun throughout these studies and my experiments, right? I can say like there's a lot to work and to learn when it comes to vision AI because it's still under development, right? You guys just released an amazing model out there. It's the fastest on instant segmentation that I can't wait to use. I mean, how can I use that, right? It's not my case. I have static imagery. And how can I use that in my process? Maybe I can, I don't know, maybe real time expose data, right? Or inferences, or let the user do something real time. That would be cool. And this is all into going to some sort of roadmap, which I spend time and trying to get to the point of becoming an expert. But I do have a decent amount of knowledge that I'm able today to contribute to the community. Like if you have a question, how do I find this? How do I do that? I'm already helping other people finding solutions on their problems. And of course, as long as it's not competing with my trading secrets, I'll be able to share information.
Mhm.
And there's so many cases. I was recently talking to a middle school class on the school about AI, and it was really fun. A ton of questions. I was showing them like, hey, you can use this. You can go to those websites to start learning. It's how you can track a ball in the field, that kind of thing. Simple things for kids to play with. They're super excited about it. But yeah, and blueprint. No, I'm not. I'm not even close to be a blueprint expert. That's one of the things. We have an amazing team. That's one of the main keys I want to highlight. The team we have is so synced up and it's so special. We have civil engineer with us. We have Nolan with us. He's who's leading this initiative. He knows so much about construction that is overwhelming. He sometimes needs to record his explanation to us so we can understand because we're gonna watch it multiple times. Like, did he got this right? It's no one has a lot of knowledge to just dump on you. And I'm learning a lot about blueprint, about constructions now. When I have a personal project at home, I know what to do. I know what kind of wood I will buy, that kind of thing. But just as a personal level, so the idea is to take this knowledge, transfer to. We are now working on getting an agent trained that will perform what Nolan will that will. Instead of having Nolan as the support, we're gonna have our agent as the support with embedding with some of Nolan's knowledge. So the person can ask the agent to say, "Hey, what about this? Let's discuss this." And that is using some Vertex points and storage that comes it's directly from Nolan to the agent that's like, hey, we do this like this. It might be a different practice for some people, but the result is the same. And we are working on that. But no, I'm not a blueprint specialist. I'm not a construction guy. I never built a house. I'm a developer like anybody else. And the only thing is that makes a difference is to have the right people right next to you. And Nolan is the construction guy we have, is the best. Yeah.
Nice. Yeah. Actually, I want to ask this question that I just saw come in from the chat from
Mhm.
Bryce, and they said, how do you embed domain knowledge into, and I'm going to say the vision models? Like, does it require the engineers to write long text explanations or something like that? What could you tell us today about, perhaps maybe even using Roboflow and creating these models and kind of getting the human knowledge from your
Yeah.
experts and into the models itself?
We as a startup, we're trying to be as practical as we can, as and fast as we can. The fastest way to collect knowledge like this, it's on meetings. We have this online calls, which we sit down, say, "Hey, Nolan, teach me how to read those elements, and how can I read a blueprint like a human would do?" And that was for us to make the point decision to get to the results we have, because we are teaching the models to view a blueprint like a human would do. And based on the assumptions a human would do, then we extract the information and take decisions. So this is the principle. That's an easy answer for you. We trying to read the blueprint like a human would do, and we sit with Nolan, which is giving us the directions what we should do with those elements like a human would do. Then I mean,
Nice.
if it is an instance implementation approach, it is implementation. Then that's my decision. Then I say, yeah, the best approach here will be object detection. The best approach here will be key point connection, that kind of thing. We even go, we try to be creative with training. We might use something that was meant to humans, but we're trying to make it fit inside something else.
I actually love that. I was gonna mention, or I was gonna ask, I think actually I saw it. Maybe it's
Mhm.
in the image you showed a little
I can
earlier.
stop sharing. Eddie can show a
Uh,
screenshot.
yeah, sure. Yeah, I think I might even have a picture. This one,
That's one. Yeah.
right? Yeah, because and actually it might be helpful to kind of go over this real quick again because I did see some questions about like processing the PDF. Sounds like PDF, there's some different things about like classification that's happening, classification
Hmm.
model to understand that. Um, but tell me what's going on here because I saw this previously and then this kind of blew my mind when I first saw it.
Yeah. This is a model that is available on Roboflow. It's a type of model, not a model itself, but it's a type of training and annotation you can do to train a kinetic type of model. This is meant to track human movements or dog movements or any living being movement, like horses, whatever. You create your little skeleton, right? And then from this skeleton, you start to train the model to learn those patterns. I decided to use that principle to create little skeletons to identify roofing connection lines. Those roofing lines are super important when it comes to estimate for roofing industry. We need to know what is a reef, what is a rake. We need to know that is a rake is always connect to a ridge, that kind of thing. So we start building logic and teach the AI how to find those patterns, and it worked really well. So this is one of the things that we used to confirm before some human touch the actual project, the AI has already done a initial work to say, hey, I have found all the identifications for you. You just need to verify if this is right. And this is how we start the finding. So we use this that was meant to be used for human or living beings into something that is a roofing system. But I mean, it was a success. It requires a lot of data to train, though. It is a ton of data. You need a ton of really well clear blueprints. I see a question here. How many blueprints were required to train your models? It would depend on the model. But usually right now we fluctuate about 2,000 blueprints. So when I say 2,000 blueprints, I'm talking about 2,000 pages of each thing we trained. If you have roofing, the ideal number is 2,000. You start getting better in 1,500s. For walls, 1,300s. So that kind of thing. It will depends exactly how hard it is to find some things and other things. Electrical, it's a ton of blueprints because they're tiny little objects. It is really hard to find, but there is methods for that. And that's pretty much what it is.
Cool. I really love this example. Yeah, like the key point detection, or a lot of times actually people refer to this kind of model as like a pose detection because it's,
Mhm.
most of the time you see it used for people, understanding their posture, understanding the movements, stuff like that.
Mhm.
I mean, I have seen one of my colleagues made a model in RoboFlow for key points where he was looking at like dog ears, and it's actually very similar to what you did here, where
Mhm.
he created a skeleton that is like it understands the base of the ear, the middle of the ear, and the tip of the ear. because he was working on like dog body language, and the position of the ears can communicate something related to the body language or the mood of the
I see
dog.
that. Yeah, I
Yeah.
see. I also see that apply could be applied to horses. Because I'm passionate about horses, and I see that if you're approaching a horse that you don't know, the ears will be like this. If you want to be approached, and will be like this, don't go in here. You're gonna get a kick. But it's pretty fun to see how we know we can leverage vision AI to find solutions to find those
Nice.
guys.
Cool. There's like a really specific question here that I was kind of
Hmm.
curious about too, which is from Logan, and the way he phrased it was, were annotations done manually or were VLMs used to
Hmm.
assist annotation? I was just watching your demo, and I was also thinking about like yeah, these days, like in the past, labeling was all very manual, right? Like 1,000 images, 1,000 objects. A human is going to have to do all of that labeling. But now, like in Roboflow and just out in the ecosystem in general, there's a lot of tools where, I label a couple myself, or I provide a little bit of context, or maybe I train one model myself, 50 images, and then it's kind of good enough to go through and retrain, annotate more of my images. Are you able to talk about that at all in terms of like manually labeling things, speeding up the process with any other models?
Yeah, we're not ashamed, and we're really proud to say that we annotated everything manually to guarantee 100% accuracy. Because we are learning and trying to introduce this project to a market that's really, can I say, picky when it comes to precision. That's pretty much what made us decide to say, okay, we're gonna annotate this with our civil engineer. So Nona put together, he's a civil engineer himself, and he put together a team of people that is in the same field. Like, because we know this in the palm of our hands, we know those elements, we know all this, we know how things end, how thing finishes. We're gonna do this manually in this first batch. So this initial batch we have done to train the model to get to a commercial version of the service was done manually. I did myself. I annotate so many blueprints, right? And now we have automation. Now we have a pipeline process. Now we have those fun things, which also comes as a feedback loop within the process. If we have a whole loop right now being created that is identifying how many adjustments somebody has to get done on a blueprint, and after the inferences and things, if that is a crossing a threshold, then we send that image back into training pre-annotated, so whoever it's now verifying on Roboflow is just a reviewer. We don't have to actually annotate. I'm sending pre-annotation material. So this is something that we are putting to run at right now. It's something really exciting that we're working on. But I mean, it's been really interesting, this whole ride, to understand how things can be done precise like we need to. It needs to be done on a pixel level. I'm not kidding. Instant segmentation, it has to be done on a pixel level, and automate sometimes does not help a process to get to to a large big box client to say, hey, I have the solution for your problem. That's why we made the decision on starting manually, but now we are moving into some automations. But so far it's been great. We have nothing to complain here. It's great.
Nice. Yeah, cool. Yeah, that also kind of knocks out a little bit of one question I saw earlier about like in the RoboFlow ecosystem.
Hmm.
I think we refer to some of what you're talking about as like active learning. I saw
Active learning.
somebody ask about that, yeah, where you
Yeah.
you may have to manually train one model, but then later you can
Yeah.
feed some more data in there and at least get an initial label that you don't have to do everything manually.
Hmm.
The saves a lot of time by allowing you to kind of just adjust things later on. I wanted to switch. I did have like kind of one completely maybe off topic and outside the scope of
Sure.
this application. Like I kind of know like this is not what you guys are going for probably, but
It's fine.
I was looking at this solution that you made, and I was thinking about you guys processing, analyzing a lot of blueprints, and I was wondering like, do you know anything about trends in house design like I was like, someday could we be saying, well, based on the data, we see that the faux Tudor style homes are coming back into fashion, or
That's
I don't
funny.
know, like we see that the ratio of bathrooms to bedrooms is uh, tied to the square footage of the house itself. I've always heard, what is it? There's like I don't know, I've always heard this thing where it's like really huge houses tend to have more bathrooms than bedrooms.
That is
Um,
true.
I would someday I would love to see like the data to like prove some of those things. So I don't
Uh,
know. Do you have any like kind of like funny observations or any trends that you've seen from looking at so many blueprints?
Yeah, the houses are definitely getting bigger. That's something that we see, and we notice like, wow, this is people are buying outside of the big central cities and central spots into some farming land and building larger homes. That's something I think it's a millennial effect of wanting to go back to have this homestead kind of vibe living going on, and like it's just three people lived in the house, just wife, husband, and a kid and just a couple and a kid and they go to a 5 acre piece of land and build a massive home just to throw parties on the weekends, that kind of thing, because it's just three of people right living in the house. It's funny. That's one of the trends we see, and the designs are so. I mean, it's very custom. We don't see a cooking cutter idea as often, unless we're talking about a multifamily, like a group of townhomes, right? We talk about like seeing a lot of single homes that's very different from each other. They don't usually now coming as a cookie cutter type of homes anymore. Even builders are making sure to have some sort of diversity on style inside of the same neighborhood. So the developers are, worrying about like, hey, I don't want the house to look exactly like my neighbors. I want something different, even on the layout, which also increases the volume of work that we have. That's pretty much the things that we're seeing. Those type of trends is like nobody wants to look like anybody else. You want to have your own custom design, and the houses are getting bigger, even if the family is small. That's what I'm
Cool.
saying. Yeah.
Nice. All right.
Yeah.
Beautiful. That I think does wrap up a lot of the questions that I prepared.
Mhm,
Before we take a look at some more of the audience questions that we had
mhm,
lined up, I had kind of like one kind of quick reminder to people. I always say something like if you're watching a recorded version of this on YouTube or somewhere else and you want to join a live session in the future, please head on over to roboflow.com/webinar. Philippi, I noticed, so I'm just starting from the top, but
mhm.
if you have some specific questions that you see that you want to answer, feel free to just interrupt me and let me know that you want to talk about those ones. But I do see there were a couple questions kind of early on that we didn't really get to, which was about the time. We sort of mentioned this, but could you talk a little bit about like how much time, like how long did it take to develop all of these models?
Mm. That is interesting. Every model behave in a certain way, which there's no standardization, like I mentioned before. Blueprints are very different from each other. And we have many different drawings. Sometimes we got drawings that are gray, green, blue, black and white, thin walls, thicker walls, full black, full white, low opacity, high contrast, low contrast. There's no standardization in the market, which is actually works as a natural augmentation. So the tricky part here is to now, when you're generating your versions on the data set, to select the right amount of augmentations you want to do. 5x, 4x, 7x, 10x. I don't know. You gotta pick that right number. And sometimes a augmentation will not work in the way that you thought, and you gotta try again, and then you try again. So I have models which I have tried 20 something times to like nail to the version of the augmentation that works for that type of model, for that type of task. Let's say object detection, right? So it will depends exactly what I want to find. If it is object detection, it is some sort of augmentations. Now I know. So now I would straight go to my preferences, and Roboflow has versions which I can just realize that kind of thing. I can just copy what I used before and do it again. So that helps. And not the same principle will be applied to instance segmentation. Instrumentation, again, works within the pixel level, right? And uh, and then the whole augmentation scene will change. I will need to rotate 5 degrees here, 5 degrees there, instead of 90 degrees rotations, which is very popular within object detection, at least for our case. That was something that shows a lot of improvement. And again, paying attention to every pixel we did, that was the most tedious thing to do. But it paid so much. I mean, it's beautiful to see. How long did it take? It depended each case by case. I don't have a day or also depend on the volume. Like for some specific task, like training walls with 1400 images. If you create a version of that, you're gonna have 29,000 images on your data set for training, right? If it also how long it'll take. It depends on the type of GPU you're using to train. It will depends how many slices you have to slice your batch. So how long it's so relative. It will depends on how much resource you have and how much you have work your data set. That's pretty much
Nice.
the answer.
All right. Yeah, good. Cool. I'm gonna try to. We have a lot of questions from people, so we might not be able to address all of them today. I'm assuming if people want to learn more, there's probably they could head on over to the Blueprint Pro AI website and submit. Is there some contact information there? I
Yeah,
have a feeling people are going to be coming to ask you
yeah.
now
They
that
can
you're a
also
computer
find
vision
me.
expert. Yeah.
Yeah, they can also find me on if they want an answer more technical. They can
Mm.
also find me on LinkedIn. And just send me a question. We're probably not connected. If you're trying to connect, just send your question so I know that comes from this call. Some random bot sending me a connection request. Uh,
Beautiful, cool. Yeah, and also just for anybody, I always like to say just my email is patrick@roboflow.com if you have some more questions about building vision AI solutions, and we don't address them here. I might not be able to answer them, but I'll find somebody to help out who could. But so let's get back to a couple of the questions. So there's a few that I think kind of revolve around the idea of kind of like understanding measurements. Like there's one really specific question from Timothy, and he says like, does the pipeline try to read the measurement on the plan? Um, and I'm going to kind of reinterpret this as like, are you doing OCR models at any point in the pipeline? Or are you just making kind of like measurements based on what you observe from like the pixels? Can you kind of talk about that at all? Like understanding the text that's on the page, things like that.
We do both.
Mm.
It depends on how the blueprint comes in. There is approaches where we need to use some natural visualization, and there's some that we need to do some OCR. It will depends on the blueprint. The blueprint will tell us the measure, and then we have an algorithm that will calculate and will take that information into real calculation and transform into, the measurements that we need to find the right amount of lumber, the right amount of materials, or the area of something. And we do have a algo for that, but we do read those informations from the blueprint.
Cool. All right. Nice. There was also a few other questions I saw that were sort of related to like file formats that you're accepting. For example, this one touches on a couple different things from
Mhm.
Jose. For mechanical engineering, is there a version to extract the like identification part or some specifications, dimensions from a blueprint, for example, coming from
Mhm.
SolidWorks or from
We
CAD?
we
Yeah.
have on the roadmap a project where we're gonna connect with the farming API from Autodesk that
Mm,
will allow us to ingest those Autodesk type of files. Right now, we only works with blueprints that are coming as a PDF or
mm,
images. Sometimes PDF produces metadata uh, when the designer decide to check the box to export them. So sometimes they don't share technical information with us. It is locked in. But the RAG we do have a RAG that extracts as much information as we can from that PDF file, even deeper into the PDF metadata. So we're doing everything we can to collect information from that PDF.
Cool. All right, nice. And then actually this kind of leads in real quick. There's a few here, raster images, pure raster images, bitmapped without vectorized guidelines. There's one question,
From who?
3D question mark. I'm kind of wondering maybe like
3D.
there. Yeah.
We are building a 3D model based on what we find.
Mm.
And it's coming soon, probably sometime next year. It's pretty cool, very exciting. I cannot give you more details on that because it's on the working, but we are building 3D models very soon.
Beautiful.
Hmm.
There's one actually here from Daniel. We might have already retreaded this, but he said, how do you calculate measurements, square footage from PDFs if the textual information is missing? Do you fall back to geometric analysis? I think based on what I've heard, the answer is yes. But do you have
Yes.
anything to add to that?
No, that's the right answer. We do geometric analysis, and we do have an algorithm that will find those sizes and use them for real calculation. Hmm.
Cool, nice. I see there's another one that we already answered. Large amount of models. Good lessons. Ooh, good lessons learned. This comes from Bowen. With such a large amount of models, I'm sure starting the annotation process was daunting. We kind of talked about this already, and you
Little
did
bit.
talk a little bit about kind of
Mhm.
like active learning. But like, yeah, any good lessons for other people who want to create their own custom vision AI models?
Yeah. The
If you were going to start over again today.
hmm I would not do anything different. One thing that I will definitely recommend to my people that is out there trying to build any solution, right? Not just this case in particular, it's to try and understand image pixel density. That's something that I learned really on in college. People just judge image by what it is. But image has a ton of information that goes within image, like what is the DPI you're using? What is the PPI you're using? Are you exporting this in what kind of size? Do you have access to clear images? What is the right size to train your model? Those are kind of things that I would advise anybody that is starting on image AI to have great success is start to pay attention to your source, to what you're using to train. Some people will train with the trashiest image they can find online on Google. So don't do that. If you're really trying to build a serious business, buy those better images as possible. Yeah, DPIs is really important. I see here a comment. And because there it lays the quality of your annotation, and trying to match your training with your inference. That's another tip I would do.
Nice. On that, I also really like to start off with the question of like your data. Are you training with the right data? A few weeks back, we did an interview with somebody who developed an app for Audi, like the car company, and they use their mobile phone to scan like features in the car. Like, I don't know what that light means. And then you can just point your phone and then it'll find that light and then give you more information. And then these models were trained in Roboflow. And, one funny story that they told me was like, they started off with really beautiful images captured from a DSLR.
Mhm.
Um, but then they realized, well, everybody's going to be using their phones to take pictures, and the
Exactly.
DSLR images, they're not good. Like the model's expecting that, right?
Hmm.
I guess my question to follow up for you based on this is like, do you find like, are you getting high quality images from people who need to analyze the blueprints that kind of reflect the data that you've trained on? Tell me a little bit more about that, like getting the right training data.
Yeah. The thing I just mentioned before is like trying to match your inference with your training. Like your example you use is perfect. If people are using phone cameras to infer, your trainer is supposed to be on top of the same type of data, the same type of images. So real phone photos or videos, if you want to do frame by frame or real time inference, should be using the same input for the output. In our case, because those images come from a PDF, usually PDF, it's a type vector EPS file, and we're able to choose what kind of quality we want. We're able to choose what kind of DPI we want. We can choose that because it is a vector. And that is also used to perform inference and also used for training. So it's exactly how we're trying to be in the seat of who is using the software to then get the quality of inference we want to. So this is definitely the case. Same as Audi did, trying to mimic the users using phone cameras to train to build the data set to then offer inference. It works for any case. That's a principle that we should put in the Bible. Yes.
Beautiful. Cool. That also kind of knocks out another question I saw earlier about a little bit like pre-processing things. Let's see, maybe there's we probably have like time for maybe one or two more questions.
Mhm.
Um Somebody early on asked about Sahi. So this is for detecting kind of like small objects. Do you
Mhm.
use tiling like Sahi to identify rooms and objects on
We
large
do
floor plans?
Yeah, we do not use Sahi. We develop our own tiling inference. That was something that we decided to do. Sahi was giving us some headaches. I will not gonna lie to you. If you're trying to use Sahi, it is available, it's out there, but it does not work. It did not work for my case. And try use Sahi. Sahi is really efficient to trying to find small objects, but try to build your own version of it. It might be more efficient. In my case, it was. I was able to build something better, customized to my case, that does exactly the same thing.
All right, beautiful. All right, maybe my last question for you, and we'll see how we want to handle this one. For a moment, I was thinking maybe I should answer this one
Mm.
from Samir. What are some efficient and key practices to configure and keep in mind while training models on RoboFlow? I think it's going to be more interesting. Do you have any best practices for like if you're using RoboFlow?
Yeah, we're trying to match the version that have on Roboflow to the version that we deploy. So if version shows V21, that's my API version for that specific model. So I name my file, I name everything I can on my APIs, so my inference APIs to match that training session. So I know exactly what's being used or what configuration was used on the last model I trained.
Beautiful. I
That's a
like
simple, yeah, simple matching name. It's don't complicate, right? Make it simple for yourself.
we're in the year 2025, and the recommendation is make sure you have good basically folder naming conventions.
Right?
This is good. Never, I totally agree with this.
Yeah.
All right. Well, apologies to everybody who submitted a question, and we might not have answered it today. But again, feel free to send me an email, send me a message. I'm sure there's plenty of ways to get in touch with Filipe. Thank you so much for joining us and spending your morning with us here chatting about Blueprint Pro AI. Congratulations on everything that you've done creating this cool solution. Yeah, do you have kind of like any sort of like any final words or things that the audience should check out?
Sure. Thank you so much, Patrick, for having us, for having our company here today. It's been a great partnership within Roboflow since the beginning. You guys provide us exactly the right amount of resources we need. When the time came, we were able to escalate to a enterprise level, easy. No, I mean, have no complaints. You guys will have always my praises, and I can prove I'm not getting paid for this. Okay, I'm telling you the truth. The truth. Um. And so glad, so happy to be here. Thank you. I hope I can collaborate more with the community. If you guys have any questions, please let me know. I'm on LinkedIn and we can follow our company as well, Blueprint Pro AI. You can follow us on LinkedIn. We're always going to post something related to this field, something we have discovered, something that is about to launch, customer client relationship we have, those kind of things, the business life. And that's pretty much what I have. And then I say hi to all my fellow Brazilians that I see. I see all Brazilian names popping right here in the chat, which is fun. Thank you so much for all the people who joined us. Yes, love you guys. There's
Beautiful.
more popping up. That's it. Thank you. I appreciate the time.
All right. Thank you so much to the audience for joining us today and your questions. And again, thank you, Filipe. Everybody, enjoy the rest of your day and go have fun solving some complex vision challenges with AI, hopefully. All right. Take it easy, everybody.
It is a thank you. Have a good day. Bye bye.